Have you ever gazed at the sky and wondered about those white trails left behind by airplanes? These are not just random clouds. They're contrails, streams of condensed water vapor created in the air by aircraft engines at high altitudes. But what if someone told you these contrails are more than meets the eye? Welcome to a world where a section of people are convinced that these are chemtrails, not harmless water vapor but chemicals deliberately sprayed for sinister purposes. They argue that these trails are part of a secret global conspiracy involving weather modification, population control, or even mind control. Sounds like a plot straight out of a science fiction thriller, doesn't it? Now, before we dismiss this as pure fiction, let's remember that the most intriguing mysteries often lie hidden in plain sight. So what is the truth behind these chemtrails? Let's dive deep into this intriguing theory and uncover the truth. Before we get into the conspiracy, let's clarify what those white trails actually are. Picture this: an airplane cuts across the sky, leaving behind a long, white streak. You've probably seen this countless times, right? These streaks are called contrails, short for condensation trails. Contrails are a common occurrence in our skies, but what exactly are they? Contrails are essentially artificial clouds produced by aircraft. When an airplane flies high in the sky, its engines emit exhaust gases. These gases are hot and packed with water vapor. Now at high altitudes, the air is incredibly cold, often below freezing. When the hot, moist air from the aircraft exhaust meets this cold air, it cools rapidly. This sudden cooling causes the water vapor in the exhaust to condense and freeze into tiny ice crystals. These ice crystals are what you see as contrails streaking across the sky. The formation of contrails depends on specific atmospheric conditions. They typically form at high altitudes, usually above 8,000 meters, where the air temperature is below freezing. The air also needs to have a certain level of humidity. If the air is too dry, the ice crystals will evaporate before they have a chance to form a visible contrail. Contrails can persist in the sky for varying lengths of time, depending on the atmospheric conditions. If the air is dry, the contrail might disappear almost as soon as it forms, as the ice crystals evaporate back into water vapor. But if the air is humid, the contrail can last for several hours or even an entire day. During this time, the contrail can spread and become more diffuse, creating a kind of cloud cover. So there you have it. Contrails are a totally natural phenomenon, a product of the interaction between aircraft exhaust and cold, humid air. They're essentially clouds formed by aircraft. But here's where things get interesting. If contrails are just harmless trails of ice crystals, then what are chemtrails? Are they different from contrails, or are they one and the same? So, contrails are essentially clouds formed by aircraft, but what about chemtrails? Let's delve into that in the next segment. The chemtrail conspiracy theory didn't just appear out of thin air. It was born in the late 90s, amidst an era of growing distrust and rapid technological advancement. A single academic paper, misinterpreted and misconstrued, ignited the first sparks of suspicion. The paper discussed the potential for atmospheric geoengineering, a concept far removed from the sinister plot many would come to believe. Key figures in the conspiracy community, like William Thomas and Richard Fink, fanned the flames, propagating the idea that contrails were actually chemtrails, laced with harmful substances for unknown nefarious purposes. Internet forums and social media platforms became hotbeds for these discussions, allowing the theory to spread like wildfire across the globe. These figures and platforms, amplifying fear and suspicion, played a pivotal role in the birth of the chemtrail conspiracy. The theory evolved, becoming more complex and far-reaching, drawing in countless believers. Understanding the origins of this theory is crucial to debunking it. It's time to pit contrails and chemtrails against each other in the battle of science. To begin, let's remember that contrails are condensation trails, created by the exhaust of jet engines. When an airplane soars through the sky, it burns fuel, releasing water vapor. As this vapor comes into contact with the colder air at high altitudes, it condenses and freezes, forming a visible trail of ice crystals. The duration and spread of these contrails can vary based on atmospheric conditions like humidity and temperature. On the flip side, the chemtrail theory claims these trails are more sinister. It suggests that airplanes are intentionally releasing harmful substances for various nefarious purposes. However, the evidence supporting this theory is often anecdotal, based on visual observations rather than scientific data. So why can contrails sometimes persist and spread, leading to the misconception of chemtrails? Well, it's all about the atmosphere. If the air at high altitude is dry, the contrail will evaporate quickly. But if the air is saturated with moisture, the contrail can persist and even spread. This can create a cloud-like appearance, which might be mistaken for a so-called chemtrail. Now let's talk about the substances supposedly found in chemtrails. Proponents of the chemtrail theory often list harmful chemicals such as barium, strontium, and aluminum. However, these elements are also naturally found in our environment, including in the soil, water, and air. Therefore, detecting these elements doesn't necessarily mean they're being sprayed from airplanes. Moreover, rigorous studies have examined thousands of air samples from around the world, and none have found evidence of the supposed chemtrail chemicals at levels that would be harmful. In contrast, we have ample scientific evidence supporting the formation and persistence of contrails. The chemtrail theory also lacks a plausible explanation for how such a massive global operation could be carried out without detection. It would require an unprecedented level of coordination and secrecy involving countless individuals, organizations, and governments. When we examine the evidence, the idea of chemtrails starts to evaporate. The chemtrail conspiracy is a prime example of how misinformation can spread. This misinformation isn't benign, it has a real impact on society. It's not just about one isolated theory, it's about a pattern of misleading narratives that can influence how we perceive and interact with the world around us. Consider the chemtrail conspiracy. Thousands, if not millions of people genuinely believe that the white trails left by airplanes are nefarious chemicals, designed for everything from weather manipulation to mind control. This belief persists despite the scientific consensus that these trails, or contrails, are just harmless water vapor. This widespread belief demonstrates the power of misinformation. It showcases how a seemingly innocuous falsehood can take root, spread, and persist in the public consciousness. Misinformation like this can shape public opinion, sow fear and mistrust, and even influence policy decisions. But why does misinformation spread so effectively? Part of it is human nature. We're hardwired to seek out explanations to make sense of the world around us. So when a narrative like the chemtrail conspiracy presents itself, it's easy to latch onto it, especially when it seems to explain something we don't quite understand. However, there's a countermeasure to misinformation, and that's critical thinking. Critical thinking encourages us to question, to probe, to seek out evidence before accepting something as truth. It's a skill that can protect us from the tidal wave of misinformation that threatens to sweep us away. Take the chemtrail theory, for instance. A critical thinker might ask, what evidence supports this belief? Are there credible scientific studies that back it up? What do the experts say? And when they do this, they'll find that the theory doesn't hold up under scrutiny. Misinformation can be as persistent as contrails, but with knowledge and critical thinking, we can dispel these unfounded theories. It's a reminder to us all to be discerning, to question, and to seek out the truth, no matter how uncomfortable it may be. Because in the end, the truth is always worth pursuing. So, what's the verdict on chemtrails? As we delve into the final layer of this intriguing topic, let's take a moment to reflect on everything we've discussed so far. We've navigated the origins of the chemtrail conspiracy, dissected the science behind contrails and chemtrails, and explored the power of misinformation. Now, it's time to tie everything together. Contrails or condensation trails are simply the result of jet engines expelling exhaust, which then freezes in the cold upper atmosphere. This process forms long, white trails in the sky, which can linger for minutes or even hours depending on atmospheric conditions. But what about chemtrails? The theory, steeped in suspicion and fear, suggests a more sinister explanation: that these trails are composed of harmful chemicals deliberately sprayed for various nefarious purposes. However, this theory lacks concrete evidence and is largely dismissed by the scientific community. The chemtrail conspiracy thrived in an environment fueled by fear and a lack of understanding. Misinformation can be a powerful tool, especially in the age of social media. It's easy for a theory to gain traction when it's shared widely and rapidly without the necessary fact-checking. But as we've seen, the science doesn't lie. Numerous studies from reputable organizations like the Environmental Protection Agency and the World Health Organization have consistently debunked the chemtrail theory. They've shown us that contrails are not a cause for concern, but rather a natural byproduct of jet engine operation at high altitudes. In fact, many so-called chemtrail samples collected by conspiracy theorists have been found to contain nothing more sinister than ordinary jet fuel residue and common atmospheric pollutants. So what can we learn from all this? It's crucial to question, to seek out information and to think critically. But it's equally important to distinguish between valid concerns and unfounded fears, between fact and fiction. The next time you look up at the sky, remember, not everything is as it seems.